the cloud. All right, so everyone can see me, everyone can hear me. And we got the recording sign going. So I'll get started. So nice to meet all of you guys, right? Not really meet, but I'm one of the tutors. I'm Thomas, one of the tutors for DMDB. I'm from Australia. Let's see, anything else? So one of the things is I haven't really done, so I'm not a bachelor student from ETH, so I haven't really done DMDB before, but all of the concepts for databases, this week is SQL, all of these concepts, they've been around for 20 years. They've been teaching the same thing for 20 years. And all these ideas are just so ubiquitous that you can learn it anywhere, teach it anywhere, and use it everywhere, right? And so it definitely comes in useful a lot. If I'm speaking too fast, can't understand my accent, something like that, just feel free to ask me, tell me to repeat the same thing. I don't mind, right? And so yeah, let's talk about the format today. So we're doing basically a similar thing to Wednesday. We're talking about SQL hands-on, right? Interactive session. We're going to be going through a sample data set, looking at some queries. And with these queries, we're going to I'm going to be asking you to help me write these answers, but also guide you through my thought process in writing these SQL queries, right? And of course, feel free to unmute yourself whenever you want to talk about things, right? Interrupt me if I'm talking with your mic, or of course, just ask questions in the chat if you want. And so this week, again, SQL, and last week you covered lots of the basics, right? Selections, projections, joins, right? I don't know if you did aggregations, but we're going to have a bit of a reiteration on those concepts in this week, but we're also going to talk about some of the more complicated things, including more complex queries with aggregations, more complex queries with nesting, right? If you've looked at the SQL exercise for this week, we have some pretty long queries there, and I'm going to be going through the thought processes to work with those, as well as talking with a completely new schema, right? So dealing with a new schema, which becomes a very important thing for when you're in an exam situation, get presented with something you haven't really seen before, and how quickly can you think about this schema, right? Given an English query, how can you write something to fulfill that? So I'm going to start sharing my screen. Desktop 1. Nice. All right, so can everyone see my screen? Yep, great. Let me just get this here. Sweet. So as you might be able to see, the sort of database we're working with today is a music database. This is discogs.com, right? If anyone sort of liked collecting vinyls, listening to physical music, you probably already heard of this website, right? And so we're working with this today. And so this is just the basic look as to what it goes through. We can explore and then sort of see, for example, these artists, right? And for example, this first artist, look through all the tracks, right? Look through versions of this release. So for example, how many times have they released a vinyl record with this album? What are the tracks on it? What are the sides? Stuff like that. And so that will be our database for today. And of course, I don't know, you haven't received the sort of Katacoda scenario for Wednesday just yet, but very soon we will have 2 scenarios for both of the hands-on sessions with both of the databases available, and we'll have all of the queries that we talked about. They'll be there on the Katacoda so you can follow through. But for today, I'd just like you to just watch my screen, make suggestions when I ask for them. Okay. First thing we got to do is sort of explore the schema. Does anyone remember the commands that we would use to sort of look at what tables there are and look at the schema of each table, or any other way that you would do so if you were given this database? Yep, \dt. So \dt is a Postgres command, a special command, right? We can look at this and we see all the tables that are in this database we're connected to. And so we see we've got artists, We see you've got release by, releases, and tracks, right? So very standard things. And then in a similar vein, we can say \D, look at each release, right? Or look at each table. And then we sort of see the basic schema in this case, right? We have an artist ID, integer, right? And modifiers, not null, null. We sort of talked about this last on Wednesday, right? And we'll go through it slightly quicker today. Right. And of course, we can have a look at all of the things from the artist table, right? Sorry. And it'll give us a very quick schema solution. Let's wait for this. And it definitely takes a long time, right? This is a pretty big database. Let's see. Oh, and it looks completely horrendous, right? Because there are a lot of columns here. Let me just. It still looks horrible. So. So we have this sort of schema, and we can look through and look at all of the basic sort of commands that we're going through, and just look at the first 5 rows of this, and we see artist ID, a name, a URL, real name, and a profile, right? Just the description, and this will all appear on the website if we're looking through those. Right. Okay. Likewise, we can look at the releases schema. We have a release ID, released, title, country, genre, and it says here character varying, right? And so we have the idea of a character field and a varchar field, which is what this is referring to. So does anyone remember what the difference between those two are? Character has padding, right? So yep, in the physical sort of representation of this field, character will sort of pad all of the empty characters or anything that doesn't reach the maximum length with empty characters, right? In sort of an application standpoint, we can talk about how varchar allows you to put a variable length string in that field. So anything that goes up to 250 characters. And then finally, let's look at the released by. And it just has a released ID, right? An artist ID. And we can sort of infer here that release ID and artist ID should be foreign keys that are pointing to the releases and the artist table, right? And that's just sort of our inference right now, right? And we all covered all of this yesterday, or rather on Wednesday. So let's go through it very quickly, right? Insert into artists, right? Values, and then I'll put in a foreign key, or rather a artist ID, right? And then my Dan. And then this is a very basic insert query. Right, done. And then we look. Again, we just get that one column that we inserted in. Okay. Now, we also talked about how we can specify the column names that we want to insert, right? So into artists. Right. And then again, let's search that through. And so we talked about how if we're using this sort of specifying the column names or the attributes that we're inserting, we have 2 sort of advantages that we're talking about, which is firstly, we can add them in any order, right? If we're doing sort of, we can add name first, artist ID, sort of a semantic benefit, right? And we also talked about how in doing so, we can omit fields and just say, for example, named parameters in Python, right? we can sort of omit fields and skip further down the line if we only wanted to add in, say, the URL without it thinking that it's accidentally the name. Right. Now, let's see what else. Let's say if I were to write this query, right? What would happen here? Yep, key error, key constraint violation, right? Error, duplicate primary key, are all similar things for what we're talking about as, right? Duplicate key in Postgres, and we're talking about a violation of the entity integrity constraint, right? Which is saying that every single tuple has to have a unique primary key in this case, right? In the terms of the relation. And if we were to do this as well, what would this return us? Okay, so we'll just talk about, so I'll just run this query and we can all see, right? And this, sorry, my bad. Wait. Right, so this works fine, right? I sort of forgot about the schema, but this works fine. And the main idea is that there's no modifier on the name column that says it's not null. So if we were to find that there, we notice that name gets put in null. And of course, if we don't put in a primary key, and it's a bit weird for this schema because only the primary key has the not null modifier. But if we were to omit that, of course, it would tell us, you know, what are you doing, right? Just get out of here. We can't have no artist ID in this insert, right? So let's go back to the release by. And one last insert, right? Some random stuff here. And what would this most likely? Can we insert with null in it? Okay, so that's a good question. And let me just sort of skip this here, right? And we'll give it a shot. So do you want to try inserting with null in the primary key or null in the second band name field? Okay, second field you think is doable, right? So again, and yes, it is doable, right? And of course, if we omit it completely, right, null is the state, it's not a value, it's the state that sort of states there's an absence of a value there. So if we take it away, then it's going to put null, right? But because null is not a value, that means if we try to insert it here as a primary key, it's going to say it violates, well, here it violates the not null constraint, right? Because it is null. Right? But if we try to insert a null value into another, I guess it doesn't really make sense because you'll never have a primary key that doesn't really have a not null constraint. But null, again, is a state, it's not a value. So it can't be placed as a, or it can't be inserted as a key in that case, because it's not an identifier. Yep, good. So yeah, going back to this previous query. Here, So what would happen if I tried to insert this, right? And I'm sort of implying the fact that both of these IDs don't exist in the release ID table or in the releases table in the artist table. Does anyone have an idea of what would happen? Should work, right? And why do you say that? IDs aren't checked, right? And so yes, that's following a very, it's sort of that line of thinking, and we can definitely try it here, right? Integer out of range because my numbers are too big, right? And it does work here. And very quickly, let's check, for example, the artist ID table. Right. Oh, there is actually one here. So that is a very poor ID to use. No, there's none with this one. Okay, and so this one still works, right? And so what Kari was saying was that the ID isn't checked in this case. And what this sort of implies is that there's no foreign key constraint on the table. Right? And if we go back to sort of looking at this artist table, sorry, it doesn't state that there's a primary key, or rather a foreign key on this, a foreign key on this table. Okay, and this is what is meant by IDs aren't checked. So of course we can add a foreign key to the table using the alter table command, which is sort of a lengthy command if we're going through. And again, these sort of alter table modifying the schema aren't really things that you have to know off the top of your head. They're sort of things that really only get run a few times during the lifetime of the database, right? And in terms of an exam where, well, no, I can't say exactly what's going to be there. Where do we see what attribute is the primary key? So in this case, released by pre, it says indexes, and it doesn't really say too explicitly here. I wonder if I can find a more. Okay, give me a second. So it still doesn't tell us here, but in this case, it implies as an index on this release by p key constraint. That's the name of the constraint, right? And the primary key is on release ID, artist ID. If you sort of have, if you wrote the schema in the first place, or if you copied a command to write the schema, then you'll also know that it says primary key next to the fields under the create table field, right? And of course, in most exam situations, we will tell you exactly what the schema is using sort of the same idea as the SQL exercise that you have. Okay. And why not write from every table in order to be sure to have the access in the data to the data we want. So do you mean by here that if you're saying select all from artists, right? And you want to find some information which isn't in the artist table, and you're thinking, you know, if I want to be sure that it's in the table we want, why not just say from artists, right? From artists releases, it completely copied it, but yeah. Releases, you know, released by, right? So sort of taking away the thinking from writing the query and just saying, let's put all of these queries in the from clause, right? And I'm just going to retrieve whatever I want from there, right? And this is sort of like, again, this is sort of like wasted work in the sense of the join, right? If you have a small co-op next to you and you have a big co-op like, I don't know, 30 minutes away, right? And you know what you want is in the small co-op, then why would you walk all the way to the big co-op to get it, right? It's mainly just you don't want to spend the extra time in running the query to join. For us, it's okay. We're sort of just sitting here saying typing, right? Comes back in 1 second anyway, doesn't really matter, right? But if you're running these queries thousands, you know, millions of times, right? So we need to make sure first where our data is. So yeah, we got to sort of learn the schema, right? And just check sort of which columns are in the schema, which ones we need, and is that sort of what you mean, right? We sort of just got to learn our schemas and just make sure we're only really putting in the work that we have to answer this query, right? And sort of just optimizing the speed in that case. Yes, we're good. Okay, we're going to do some more sort of exploration on this, right? Does anyone want to sort of flex their music taste over here? Give us an artist name that we can query with. And if not, I'll just go with the default that we hadn't planned. Rick Astley, Usher, Taylor Swift, DJ Bobo. Okay, I can't say I've heard of that one, right? For the interest of curiosity, I'm going to go with DJ Bobo here. Simon, let's go. Daft Punk, so sad. Okay, my name equals DJ Bobo. Yeah, you want a mixtape? 20 francs. And maybe I spelt it wrong, right? So would you spell it for lowercase, uppercase, right? I'm afraid DJ Bobo hasn't made his way over to the Australian shores just yet. No, maybe in a few years. Okay, so in this case, I don't know what the sort of casing of this artist name is. Ah, okay, here we go. Ooh, we got one. Real name, Peter Rene. I'm not going to pronounce that, not going to offend anyone here, right? Swiss singer-songwriter. Okay, so we have the artist here. That's pretty good. Okay. Yes, so the question is, can we do a case-insensitive query? I think this might be related to the sort of system that you're using it on. But in this case, what I can do is, instead of doing a case-insensitive query, exactly, Yannick, right? I can say, or rather, I can cast the name field into all upper before I do the match, or lower, right? It doesn't really matter. And in this case, it should find it much faster. Or not faster, it'll be slower to find it because it has to cast it, right? But then I don't really have to think about it. Okay, and here, right, he said that you can use like, right? And so that won't give us a case-insensitive query because it still matches the case in the string, right? But like does come in useful in other ways, right? For example, you know, I can't remember who my favorite DJ is, right? I know he had the word Bobo in his name, right? But I can't, did he call himself a DJ, right? I can't really remember. So I'm going to do name and ID in this case, best interests. I like. That should be case insensitive. I think that will work, but again, in that case, it's sort of a little bit more powerful than what you might need, right? If you know the exact name and you just want to cast the case, then you can just use lower or upper in that case, right? From artists, right? Where name, like, right? And can anyone tell me what to put in here? I know that my artist is called Bobo, right? I just don't know what the rest of his name is. So what should this field be that we're matching? Sorry. Yep. So, right, Simon got the percentage sign, right? You're saying you want to match everything before, and so the string ends in Bobo, right? And then, sorry if I mess this up, Bastian, right? He said, in this case, we're not casting up or lower, so I'm going to have to write the case here as well, right? And so this gives us the result we want, right? And again, Sebastian, okay. Open parentheses, SE, end parentheses, Sebastian. There we go. Again, we can put a percentage sign at the end of this, right? And we're saying we're going to match Bobo occurring anywhere in the string, right? And if you sort of done any regex, it's kind of like having this match here, right? And then ending it here. And if you remove the percentage sign here, it's equivalent to, or if you add the percentage sign, it's equivalent to removing match the start of the string or match the end of the string, right? If anyone sort of relates that to regex in any way, right? Okay, and that's about what we want for the selections. So we're going to move on to some basic projections, right? Looking at projections, is there a function to select all words that are similar but not the same, like here with Bobo, lowercase, uppercase? So all words that are similar, which is saying it might not necessarily contain Bobo, right? But maybe it contains, for example, DJ Hobo. You want to match him as well, right? Are you saying something like that? I'm not sure if there will be a function, right? Because that you have to use string similarity, something called edit distance, right? It becomes a bit of a pain, takes a lot of work. There might be a function in Postgres or something like that. As far as I know, it's not native to SQL. But again, if I'm wrong, correct me, because I've never tried using that, right? Okay. For the next section, let's work with another artist, right? Okay, Rick Astley, let's go. Postgres has fuzzy string matching, if I recall correctly. So, I mean, yep, again, if you want to look at that, just Google it and we'll go through it later. Okay. Very basic projection, right? Select name, sorry, artist ID, right? I think it was link, or was it URL, right? As link name from artists, where name equals risk recasting, right? Okay. And so that's a very basic projection, and it's always confused me, the idea of selection versus projection, and projection being in the select clause, right? But of course, it is something that you learn, right? And we can put in sort of literals here, right? And say hi. And this sort of goes along the line of thinking that, projection isn't exactly the same as taking the base relation, right, and then filtering out values, right? Because here we're sort of augmenting the table with a value of our own, right? So it's not sort of passing it through a filter, passing it through a sieve, right? We can also say, what if I want the artist ID twice? And we sort of duplicate the artist ID. Right? And in the same way, we're not filtering it, right? It's a projection in the sense that we're sort of taking the base table and moving it into some other view that we're looking at, okay? So we can take things that aren't there initially, or as long as it's not a field that wasn't in the table, right? And this brings us to the interesting point, right? Last on Wednesday, how these relations, they also have bag semantics, right? And things like that, where it doesn't really matter that the results have to be unique in terms of any key, right? There's no such thing as a primary key in a query result, right? Because we can have non-unique rows here, right? Unless, of course, we use the distinct keyword. Yes, particular reason, 8:44 a.m., I'm being a bit negligent, right? Any important reason? Not really. So yeah, this uppercase, lowercase on your keywords, it's all your own style, right? And it will sort of match it no matter what. These are all reserved clauses in this case. It doesn't rely on the case in order to parse it. Okay, and finally, we also have concatenation, right? I'm going to do it with releases. Does anyone have a favorite album they want to introduce to the class? Reverence. Parkway Drive. Let's go. Title. The casing seems correct here, I'm guessing. Whew. I mean, it's been released a lot of times, right? Yes, select from where, right? All of that works in lowercase. You can have your entire SQL query in lowercase. It's really just a stylistic choice, right? I like putting in the effort to hold down the shift key. Pinky hurts a little bit, right? But it looks nice to me. Okay. And from here, right, I can say, what if I just want to print a string? I'm going to print a string which takes this sort of name and also prints the genre next to that, right? What sort of function can we use? Not really a function, but what can we use to print the string? And within the same string, we have the album name and also the genre, right? Does anyone know what we can do like that? Like how we can do that, sorry. String concat, right? The double straight lines, not too sure what that symbol is actually called. I think it's a pipe symbol, right? Or the logical or from other languages. Right. So we have title, concat, and I've already written this before, right? Okay. I'm gonna limit by 10. Okay. And again, we have what we sort of want. The column, question mark column, doesn't really know. Double pipe, right? Sounds like a gnarly skateboard trick. Let's go as genre title. Oh. I think I'll need some brackets here. Oh, sorry, and there's no quotes here because it's not a literal, it's just part of the query. Okay, there we go. So if we accidentally did a query returning a lot of results, can we quit it, right? Selecting everything from artists. Right. Well, a lot of queries, right? But we take a look at this and then it starts listing, oh my God, right? And then we start panicking. And in this case, it's very similar to Terminal, depends what client you're on, right? Sometimes you might have to wait if you're on like a graphical client. But in my case, maybe you shouldn't have picked some that took so long. Okay, can the concatenation operator, so I'll get to that very soon, right? So this is taking forever. So for me, in this client, I'm just gonna press Q, right? And it should work unless it's messing up for me. Okay, it is lagging a lot. Okay, so I press Q maybe several times and it happened, right? Control C will also work, yes, correct. As long as you're on a command line interface. Right? So can this only be used for strings? All right, again, a good question. THX. Do this, concat 5, right? And again, it works perfectly fine, right? So it's going to sort of take anything that can be reasonably converted into a string, and it's going to take those and sort of convert it into something that can be concatenated first, right? And so that will definitely work. Okay. Very quickly, right? We can also do math, right? Also bools, that I'm not too sure about. So let's check that. Works perfectly fine, right? So I'm guessing these developers envision that maybe these guys will have to do it. What if the line is null? Okay, I think it will be empty, right? Let me just find where, okay. This should be null in terms of, sorry, and the name, right? Okay, I'll get to that very quickly. All right, but here, select all from artist where artist ID equals this, all right? And then let's get name concat, right? Exclamation mark. Okay. Ooh, and it does give me a null, right? And so I think I recall, because null is a state, any sort of binary operation that works on null, right, will also return null. I think that was mentioned in the slide somewhere, right? And in this case, it does return us null, even if we concat with something else, right? What if we don't write true explicitly, but using a Boolean term, a Boolean expression, right? And I'm fairly certain it will just evaluate this is null, my bad. Right, and it does evaluate to true. Right. So a lot of the things that you expect from programming language that you might use elsewhere should also work well in SQL, right? It's not completely unwieldy in that sense, right? Even though there are some things that might leave a little bit to be desired, right? Don't remind me. Okay, I'm going to pretend I didn't see that. Let's go to date, right? We have some sort of things very quickly. I got to go through this title, right? And then we have the extract function. I think we've covered this as well. And I've written this as well, at least, right? And this just sort of gets us our release here, extracts sort of date functions that help us work with the date type, right? Not strings that represent dates, but the date type in Postgres, right? From releases, right? Oh, my bad. Okay. Again, right, gives us to us as a floating point number. You know, I'm not sure I agree with that, but that's how it is. And as well, we can also get the age. Bad. Okay. Time of Cartesian product for artists. Ooh. I don't know how long you want to be here, right? Maybe I only have another hour left, so I'm not going to run that query just yet, right? But no, it shouldn't actually take too long, right? Maybe a few seconds. We'll try it soon. Right. Can we cast the floats to ints? Right. I'm fairly certain we can, just using float. I can't remember if it's float or not. Sorry. We want to cast it to an integer, don't we? I think it might be integer. Extract here. Okay. Extract. It's a function that works with the date type, right? Int. No, I'm not actually sure how to do this one, so I'll check it. We can check it later. Extract is a function. It's a Postgres function, right? A Postgres date specific function. There's a terminal running at 1 FPS for anyone else. Okay. Yeah, I'm not too sure how to sort of deal with that in that case. I might just wait a bit first before asking or talking about these functions, right? But yeah, extract is a function. We can also say day, right? Bad. This is the wrong query. And also works just like that, right? Nice. Okay, cast expression as integer, right? So a bit, again, a little bit of a longer expression that we're using to do these casts, right? But I mean, I'm going to take your word for it and say that this also works, right? Okay. So we had that question about the Cartesian product. Again, I'm not going to run the whole product, right? But who remembers how to actually do a Cartesian product in SQL? Right, just list both org tables, yep, using the comma, right? Join, right? Sort of like what comes after the Cartesian product, right? Not how you make one. But again, just using this comma operator, or rather the comma of the table. So let's select count all from artists. Okay, so you don't understand what age, year, and day from mean, right? So age is a Postgres function which works with a date type, right? And all it does is not age year, sorry, this should be age release, right? Which is the attribute in the releases table that gives us the release date, right? And that will just say how many days I think have occurred since that date field, according to the current date, right? And extract just takes syntax. So I'm going to extract the day value, right, from the released date. So these are both Postgres functions, right? I don't want to spend too much time here because it's not exactly crucial, right? But again, if you're still confused about this, feel free to just throw a question on the forum, or you can, I'll stick around for a bit after this and you can ask me that as well. Okay. So we're going to cross product artists and releases. Right. I'm going to select count because I'm very skeptical that this will run in any reasonable amount of time. Right. Okay, I've run out of patience, and this will give us the count of the cross product. It's going to be huge. Okay. Right. So in this case, it will be this count times this count, and that's the amount of rows it will return. Right. Not sure my little laptop can handle that. Just of course very long, right? And so we don't want the cross product because we're saying, you know, if I wanted to join artists with release by with releases, it's not really, you know, what I want because it's going to give me all of this chaff that I don't want to deal with, right? And so we talked about how we can sort of filter that, right? I want to say artist ID. What would happen if the count of the cross product produces an integer overflow? You guys have some nasty questions, don't you? I'm not very sure, right, about this. This is definitely a very system specific thing. I would assume that it deals with that in a slightly better way. Oh my God, there's a spider right next to me, right? Get out here, right? So I would assume it works in a way that would produce the correct result. I feel like that'd be an oversight if it didn't, right? But again, it's probably a very specific thing to the sort of database that we're using. Okay. From artists released by releases, right? Where, and we've covered this, so where artist ID, right? Okay, you know what? I'm going to take this, I'm going to copy it. It takes a while, right? Magic, I typed it so fast. Okay, so we have this query here, right? And this is a implicit join, right? We're joining using the where clause on the Cartesian product, right? Okay. I'll take 5 minutes to go over the rest of joining, right? And then we're going to take a break, 15-minute break, and then when we come back, we'll go over aggregations and nesting, right? But for now, this is our sort of implicit join. So who else recalls the other methods of joining that we can use, right? I think most of them were covered, right? The join operator, right? And so join, we have multiple ways that we can use the join operator. Which ones are there? Natural join as well, right? Join on, inner join, semi-join. I saw that question on Wednesday, right? Semi-join's a bit of again, a fairly nasty thing to talk about at this level, right? So I'm just gonna skip over that, okay? And join using, right? So again, we will give you a Calicoda scenario. I'll try to release it tonight, right? It will give you access to the database. It will give you access to everything. A semi-join, I don't think it's covered in this course at all. My knowledge of a semi-join is that it's used in distributed databases, right? But I think there's multiple definitions that can be used as well, right? And yes, this is also a public, you know, database or data API that we can use, right? So join on, right? I'm gonna copy that here. Do I have it somewhere? No. Okay. Artists, right? And then we join on released by, right? Where artist ID equals released by dot artist ID. All right, I'm going to skip the next one because it takes a bit to type out. All right. Limit by. Sorry. Totally there. All right. Then this one gets out of here. Does the on condition need to be field 1 equals field 2? Any Boolean expression, right? This is a theta join, right? Join on any Boolean expression using these two. And anytime it evaluates the true, it returns both rows, right? And that leads me to the next one, right? Also with and or. If you can composite that into a Boolean expression, it should also work. Right. Using is just a sort of a neat shortcut to lead us there, right? Artist ID. In this case, this only allows us to do an equijoin where the two fields are the exact same, right? So a little bit less flexible, but much quicker to write. For very long queries, does SQL allow brackets? Yes, right? Allows brackets in expressions, allows brackets in subqueries as well. Or subqueries, I'm pretty sure it's necessary. Right? Actually, maybe not, but the brackets do make it much more readable. So we'll see that towards the end of the session as well. Right. Natural join. Again. Okay. A natural join, does anyone remember exactly what it does? Right. So there's two main differences in a natural join. All right, there's one sort of, not main difference, but there's one quirk of a natural join and the sort of definition. Right. So does anyone remember what makes joins all attributes with the same name? Right. Ingo said he didn't like it because it's very easy to mess things up. Right. Maybe you accidentally change a schema. Right. The names change. More things have the same name. Then the join no longer produces what you want. Right. And again, let's see. Select all. That's going to be nasty, right? So select all. Oh my God. Okay. The other thing we can notice, right, is that the release ID and the artist ID only appear once in the final result, right? So a natural join, if you join two fields together, it doesn't include them both, right? It doesn't include the same artist ID field twice, whereas join on, join using will include both of them, right? So that's one of the main differences as well. Okay. And so now we're going to take a 15-minute break, right? We're going to go to 9:18 is when we're going to start again. Right, I'm going to stay around if anyone has any basic questions. Right, but other than that, see you guys in 15 minutes. Resume recording. Thank you. Okay. So again, we just talked about briefly, right, what we're going to be doing, and also, firstly, just select max duration from tracks. Terminal is 2 FPS now. No, we made it. Thanks. Select count from tracks. We've done this before. Okay. Now, one of the issues is, right, what if we only want to find the tracks, right? Firstly, a simple one. What if we only want to find the unique track names in the tracks database, right? What would we put in this query? So again, just finding all unique, distinct, right? Where does distinct go? After select, right? Like so. And we get an error here. Could not find path key item to sort. Right? Does anyone know why we're getting this error? or how we could fix it here. Select count distinct, right? That's correct. So again, SQL is sort of based off a semantic it has a semantic origin. It wants to sound like the English language, right? Sorry, I completely messed that up here, didn't I? Select distinct count title from tracks, right? Which shouldn't make it, ooh. Okay, it doesn't really make a big difference, right? But it does make a difference. And what we're looking for here, right? Distinct title from tracks. Okay. And this finds all the unique track names that occur. So again, SQL is based off semantics, right? It wants to sound like the English language, right? So select count. So we want to say we want to count all the distinct titles, right? It makes a bit more sense than saying we want to distinctly count all the titles. And also distinct count is slightly different in the sense that it takes the distinct of the count rather than counting the distinct titles here. Okay. What if some of these titles were null, right? What if some of these titles had state null? Then what would this count? I guess they won't be considered, right? Correct. So it could be one way of thinking to think possibly, right? Null is technically a title, right? And so it will count it, add one to the count, right? But in this case, null again is a state, right? It's not a value. And so it won't consider that in terms of counting the distinct titles. Now we should move on very quickly. And even if you just count the individual titles, right? So if you take away the distinct and say count title, it will not consider the nulls. And that is where I missed. So when we had select count all from tracks, it gave me this number. When I said select count title from tracks, right, it gave me this number. And that's because the nulls no longer get considered, because count all counts all rows no matter what, right? But count title only counts the rows that have titles that are not null. Okay. Okay, so next, let's very quickly move. What if I wanted to find the tracks with the longest duration, right? Which keyword would I use here? Max. Yep. And we've done that, right? What if I wanted to find the tracks with the 10 tracks with the longest duration in this case? So the distinct in the select distinct count title has no effect. Exactly. If I took this one back, all right, where is it? Order by plus limit, right? And that's what I was looking for. This should not have an effect. Yep, and it's the same value as this one here, right? So the distinct only filters the final result. In this case, is only one number anyway, it won't make any difference, right? Okay, order by plus limit, right? Select duration, let's find, okay, track is tracks title, right? Select title, duration from tracks, I've already written this before. Descending, right? Okay. And this brings up a curious point, is what is the semantics of this query, right? We're saying limit 10, we're saying take the first 10 from the result after we sort it by duration, right? But does this sort of have the same semantics as find the 10 tracks with the longest duration, right? And I'm hinting at it, right? But it doesn't have the same semantics as what are the 10 tracks with the longest duration. Straight up 25 hours song. You know, if anyone wants to listen to that and report back, right? Yikes. Select count star from select distinct title from tracks, right? Result in the same select count distinct title. Yes, that should also give the same answer, right? So we're using a subquery here. And we're first filtering out all the distinct values, which is what it does anyway, and then it counts them. So it will have the exact same thing, right? So it first sorts all the tracks, right? And exactly if we're looking a bit deeper, right, which isn't covered just yet in this course, but how it answers this is it'll first sort all the tracks, right? Or in this case, it's easy to see, right? Order by duration descending, then limit 10, right? But again, this doesn't semantically say, give me the top 10 tracks in terms of duration, right? Because importantly, we have the idea of a tie, right? So let's say if I were to get limit 15, right? And for some reason, someone posted, 5 songs that have the same length, all called Untitled. But how do we distinguish between them, right? What is the order that is guaranteed here when we filter by top 10 by length? And there's no guaranteed order here because, there's no guaranteed order in a thing. Even if you order by duration, once all these durations are the same within the same duration bucket, I guess, there's no order here. And so it won't give us anything, and so that's an important distinguishing fact, right? If it says, give me the top 10 results from the query, right? Then you can use limit 10. But it says, give me the longest 10 tracks, right? And there's a possibility of tie, so we're not sorting on a distinct field like primary key. Then we have to start looking at how do we retrieve all of these at once, even though there's more than 10, okay? And that will come up very soon. Right. So just keep that in the back of your mind. Right. Okay, so let's say we want to find all of the releases that contain the longest track. How can we order on both track name and time, with time first and track name second, right? That's very simple. Order by duration, comma, title, right? Sorry, this is my bad. Does anyone know why it gave me this here, right? Instead of the longest tracks? Title desk. Yes, correct. So the desk descending immediately refers to the previous attribute in that comma chain, right? So in this case, it will order by the title ascending, right? And so, but it will first order by duration. So that's using a comma here, right? Okay. One quick thing is that if you wanted to find the top 10 tracks, right, and then sort those top 10 tracks by another field, right, you can't use this comma because it will only sort by the second field within if they have the same value for the first field, right? So does anyone know how we would sort it? Let's say we want to find the 10 longest tracks, right? And then we want to sort those by alphabetical order. What sort of thing would we have to do there? Subquery, correct, right? So I want to take this previous query, limit 10, right? And we're ignoring the semantics here for now, right? Select star from, and then we further order this query by, right, duration, or by title, sorry. And okay, so what will happen when I run this? Exactly, that's perfect, right? Subquery in from must have an alias, right? I gotta admit, I double checked how to pronounce this properly yesterday, right? So we're gonna give it an alias here as S1, right? Order by title. And then it works, right? Because you're technically saying I'm gonna convert this subquery into a base relation, which I can, not a base relation, but sort of like a table which I can then query from, right? But we need to give it a name here or an alias because otherwise it becomes a bit annoying, right? It's sort of anonymous in that sense, right? It's just one of the things that SQL requires, that if you're taking something or selecting from a subquery, it always has to have an alias. Otherwise it will not work, okay? So back to before, right? If we want to say, find the releases which contain a track which is part of the longest tracks, right? What would our query be, right? Firstly, what tables do we need, right? Always, 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 right? Look at this. We have find the releases that contain the longest tracks. Think about what information do we need? What tables does it come from? Right? Is this something that depends on the DB? I remember doing subqueries without an alias, right? And it should be a part of SQL, right? But one of the things is an alias only is necessary if you're putting the subquery in the from clause, okay? But if you put the subquery anywhere else in the query, right? So if you said where this value equals the value of a subquery, something like that, if it's in the where, right, then you don't need an alias. So only if it's directly being retrieved from, that's when you need your alias. Right? And we'll take a look at that soon. Right? Or we'll have a look at queries without aliases soon. Right? But again, I'll go quicker, right? Releases with the longest tracks. What information do we need, right? Of course, we need information from the releases table. Right? And we also need information about the track duration. Right? So we need the releases table in the track. So let's quickly bring this up, right? Select. Okay. Do we need a subquery or a join here? Right. Subquery or a join to find the releases with the longest tracks. Join, right? Correct, right? But, right, join is one way to do it. And again, that was a bit of a sort of open question in the sense that both of these work, right? Again, in SQL, there's a lot of ways to answer the same query, right? And so join is probably the way I'll do it, but you can use a subquery here as well, right? So let's find select releases.title, right? Tracks.title duration from, I'll do it like this, from releases, join tracks using release ID. Right? So just the standard using join, equi join on the release ID. Okay, and then order by duration, oh sorry, tracks.duration, descending, limit 10. Is there an efficiency difference in limit 10 and fetch the first 10 rows only? Again, this talks a lot about the internals of SQL, right? Or internals of the database system, right? But the issue is with this sort of join, right? Or with this sort of query is that we first have to sort it anyway. So we're going to have to read all of the information anyway, and then we sort of return the first 10 rows, right? And so maybe, you know, that's probably a bit too much to look into, but the efficiency difference will be smaller because you can't just directly say, give me 10 rows that are the highest, right? Unless there's an index, which again is, I'm not sure if you've covered that just yet. Right? How should we sort if we want to sort by duration? And if the duration is equal, sort by title, right? So we've covered that slightly up, further up here. Right, where you say order by duration, comma title, right? And then it'll order first by the first field, and then if they're equal, order by the second field, right? So you order by two fields like this. Yeah. Okay, so again, this just gives us all of the releases with the longest tracks, right? And ordering by these aggregations, we can also order by the aggregated value itself, right? So what if we wanted to find the titles that occur the most, right? So if we wanted to find the titles that occur the most, right, what sort of field would we sort by in this case? Count title, right? So, okay. Isn't there something like group, maybe something with grouping, right? And so yes, that was what I'm getting at, is we have the idea of aggregations where if we only had select count star from tracks, right? What it's going to do, it's just going to count all of the tracks all together, right? But that sort of doesn't really work sometimes, because a lot of the queries you want to count according to a particular field. And that's where group by comes in, right? We're grouping, right, all of the records together by the tracks field, right? And we're saying, let's just look at the result, right? Count title from tracks, right? Group by title, and I'm just going to limit it here. Okay. This isn't very good, right? So, but here you can kind of see, right? It gives you this title, and then it counts the number of rows that match this title, right? And what we're doing is we're aggregating, we're using an aggregation function, in this case, count, right? And we're applying this aggregation function to all of the tuples that have the same value of title, right? So that's what's occurring here. Likewise, we could also put max here. Then what it's going to do is it's going to look at all of the tuples that have the same title, right? And it's going to get the max of some field from there, right? So group by basically says, let's group these together. Why is the table broken? You know, maybe we can find the developer and sort of put a GitHub issue there, right? It's no clue here, right? This hasn't really happened before. But here, right, select count star from tracks, right? Group by title. Let me tell you why I do that. Right? Works on my machine, classic. And then here we can order by, right? Order by the count. Okay. And this is sort of an important point, because, how did I mess that up? Sorry, this is sort of an important point, because you're saying this count here, right? It might not make sense if you're thinking about SQL queries purely in a time-based notion, right? Which is the idea, if I define count and I select it here, don't selections happen last? Then how do I sort of order by it here? It becomes a bit difficult, right? But again, SQL is purely time invariant, right? A single statement always just gets evaluated as a whole, right? So I can order by the count here perfectly fine, right? So if we want to find the maximum, can we do max count star, or do we have to order and limit one? Right? That's a very good question. Okay, could I explain grouping again real quick? Right. So let's see. How would I do this slightly differently? So again, if we said select count star from tracks, right? How many values would that give me? Right, exactly one, right? And it gives me exactly one because it's counting the entire tracks table, right? Whereas that's not really valuable sometimes, because we don't want to just know how many tuples in the tracks table, but we want to count, for example, how many titles, how many songs have the title untitled, right? And so one way we do that is we could say select count star from tracks, right? Where title equals untitled, but that only gets me untitled itself, right? And let's say I want to expand even further and I want to say, well, let's count, right? Let's do that sort of what we just did, right? Where select count star, where title equals untitled. Let's do that for every single unique title in the table, right? And so what we're going to do is we're going to say, let's take and find all the tuples. Okay. Let's take and find all the tuples, and I'm going to put them together. Right? And then I'm going to count that first. So I'm going to count all the titles that have untitled, and then output that as a row. Right? Then I'm going to count all the titles that have intro and output that as a row. And so what we're doing is we're grouping tuples together by the title field. And then we're counting all of those groups, right? Does that kind of help a little bit? Could you maybe walk us through how this query gets evaluated? I'm a bit lost. Right? What gets evaluated first? What gets selected? When does the ordering happen? Right? And this is something which doesn't really happen, I guess. Well, not at this level, okay? And we've very briefly mentioned how SQL is a declarative language, which says you tell it what you want it to do and how it implements that, right? So when it selects these values, when it orders these values, right, those depend on how the query gets optimized, right? And so you will learn much more clearly about this later in the course, right? But the idea is that when you write this query here, there's no guarantees as to when it gets ordered, when it gets selected, right? When it gets limited, there's no guarantees in this case, right? It all depends on how the optimizer decides to order them. That would be the fastest, okay? And so when you look at an SQL query, you have to determine what it does, right? And that's all you know at a surface level, right? You don't know how it does it just yet. Okay. The semantic of this query in particular. By title, order by count star. Okay. So what this really does is we know that with the group by title, we know that it takes all the unique titles and counts how many times they occur. That's the semantics in this case, right? And so are you asking about the order by count star, or are you asking about this part, the group by in particular? The order by count star? So Michael, that's correct, right? Sometimes you can just say, if we want to give it a name anyway, right? Say count star as frequency, and then we can say order by the frequency descending, right? And this also works. It should work exactly the same. Right? So yeah, I do want to sort of get onto some more of the group by queries, right? So Douglas, if you have more, or if anyone is a bit more confused about this group by towards the end of the session, I'll stick around for a bit longer, right? Stop the recording, right? And then we can discuss it more in depth. Is that okay with you? So we have this idea, we can order by the frequency descending, right? And then we also have, so what if we want to say, let's find all the titles that occur exactly 42 times, right? How would we do that? What keyword would we have to introduce into the query? Where? Okay. So by title, where frequency equals 42. Okay. Okay, error at or near where, right? And does anyone else know why this doesn't work? Have to use having, right? Exactly. So when we're using the group by clause, if we're dealing with any aggregate function, right? Dealing with any aggregate function, then we have to always refer to that using the having clause, right? More specifically, right? Yes, so where is evaluated before group by, right? At some levels, that's true, right? I wouldn't exactly think of it in that way, right? I would sort of think about that where is related to filtering, where is related to filtering from the tracks table directly, right? Where having has to relate directly, or rather anything that results from the group by has to use the having clause. Okay, so anything that uses an aggregated value from the group by has to use the having clause, right? Because the count star doesn't belong to each individual tuple in the tracks table. Right? So we can't use a where, because where sort of checks each individual tuple in the tracks table. Right? So in a way, Romero, what you're saying is very correct, right? Whereas having has to look at what exactly can we select then using a group by query? Can we select a column that's not in the group by clause nor in an aggregate function, right? Okay. Let's finish this one first, right? Sorry. By title, having frequency, sorry. This one, I think we need to do count star. Al, we'll get to that very quickly, right? Very good observation, okay. But first, Federico's question, right? Can we select a column that's not in the group by clause, nor in an aggregate function? Okay, nor the value of an aggregate function. Okay. So let's go back to this, select the most frequent titles, right? So I want to find from tracks where title equals, okay, anyone have the name of the song you want to add on for me? Right. If not, I'll just go for a basic anything. Right. Can't hold us. Okay. So there's a quote in here. I'm not sure if it stores it like that. Probably do lower here just in case. Okay. Postgres doesn't allow double quotes in the strings, only single quotes. So I'm just going to go for Anaconda for now and keep it simple. Okay. Select count star from tracks where lower equals Anaconda, right? So we're counting all the titles that have the name Anaconda. Okay. Now let's say we want to include the title here as well. Okay. So we want to say, I don't want to just know the count, even though I'm filtering by Anaconda. How do I also include the title? Right. Wouldn't work. That's correct, right? Because count star aggregates things at a table level. If you're aggregating at a table level, you no longer have the notion of an individual title, okay? Which is why here, what we're going to have to do is we're going to have to add the group by title clause here. Okay? Because at this point, you're no longer aggregating count at a table level. Right? Okay. With backslash, I think so. Backslash as an escape. I'm not sure what the Postgres escape is in this case. Maybe you have to use a special thing. We can check that, or maybe just search that up as well. So select title count from tracks, right? We're not aggregating at a table level anymore because we put the group by title, right? We're now aggregating at a unique title. So that means that title is now a field of this relation. Right? So yeah, maybe that was just my command line, which is sort of not parsing that correctly. But are there any questions about why this works and why select count star only, or why not grouping by doesn't work? Why does where work here, even though you use group by, right? Because we're not filtering by the count. Right? What we're sort of doing is we're sort of saying we're going to select. Yep. What we're sort of doing is we're saying we're going to select all of the titles, right? From tracks where the title is Anaconda. So we're going to select all the tracks that are Anaconda only, right? And then we're going to group by the title, okay? So in this case, we're filtering on the tuple itself. We're filtering on each individual tuple and only returning Anaconda, right? And then we're grouping by the title. And in this case, there's only one title in the entire relation. Right? But since there's only one title in the entire relation, it still sort of says, we're still going to group it. It's going to give us the title and count for Anaconda. And now we can include the title in the final projection. I don't understand why title doesn't work in the previous example. Right? So again, let's say we just selected count. Okay, we just selected count star from tracks, right? Where title equals, yep, let's go back to this one. Where lower title equals Anaconda, right? Again, we have the idea that it only returns a single row, right? Counting the number of tuples in the tracks table where the name is Anaconda. Okay? That only returns a single row. And it's because it's at entire table level. This where clause doesn't affect, or it doesn't sort of relate to the count function, right? What it's saying is it's counting whatever this returns, right? And it also works here, right? But we're just counting the entire relation that gets returned, right? Even after we filter it with Anaconda. And because we're counting it that gets returned, we can't say get the title from here. Because title is an attribute that belongs to a single row. It belongs to a single tuple. And even though we're saying, you know, but there's only going to be Anaconda here anyway, right? But in a sense, SQL isn't smart enough to say there's only going to be one distinct title here. So let's just return it here in title, right? Because even here, it's trying to find for a single title belonging to a single tuple, right? But because we aggregated the whole table, there's no longer the sense of an individual tuple. You can't retrieve this title from it. And so that's why we need to group by. Where is for, yep, so where is for the table entries, right? Where filters on the individual tuples, having filters on the aggregation function values, something like count, right? Having count. And again, if you are still confused about that, stick around at the end and I'll sort of give a longer explanation. Okay. So I think, was it Al who mentioned titles that occur 42 times, right? So whatever this is, right? He said, can we do this in a subquery? And so yes, that's definitely correct, right? We can do this in a subquery and we can say, firstly, let's select count star, right? And we also need the title here. Right. By title, right? And then what we can do is we can write a subquery, right? From, I should probably take away this, right? From here. Right. And again, we always have to give it an alias. And then finally, we can say where star equals 42. Okay, so what will happen if I run this query? Should work, right? But again, because we're using this count function, right, it's trying to aggregate again, right? Because there's no field called count in this individual thing. So let's say we were to just run this query, right? Now, and you notice how, very quickly, oh no, I messed up. Yep, so you've already jumped to the answer, right? And this is taking a while to run, but the main thing is that this count star field, right, when it gets put or outputted as a table, right, it gets given a named count. It's no longer count star, right? So it becomes effectively the same as an attribute from the base table. Right? So now we do count here. And so it should also now say, you know, now we're looking at this count attribute which gets created. Right? And so that works fine. Okay. Select all. Yep, gives me a lot of them. So firstly, so if we select title, but we don't group by title, this will give an error. Sorry, ever. Yeah, this will give an error. So correct, right? As we were saying, because title belongs to a tuple, right? But count counts the whole table, the tuple no longer exists. Right? Let's see. What are the runtime differences when using the subquery? That definitely depends on how it gets optimized, right? It'd be very dependent on, for example, what is in each table, right? And so it's much later. If we group by another attribute than title, right? Very quickly, let's get to that soon. Is the automatic alias count part of Postgres, or is that already implemented in SQL? So yeah, by default in most SQL systems, it will rename the count table or count attribute to count, right? And of course, you can also give it an alias yourself. So if we would group by another attribute than title, let's just look at it in this way. Select all from, so let's group by duration. That might take a long time. Let's group by release ID, right? Okay. So given this result as part of the group by release ID, right? What do you think will happen if you try to filter by title as well? Error, right? Because title no longer exists if we're grouping by something else. Right? And that's why the other query worked, because title is here as part of this group by table when we group by title. And that's why we can then retrieve it as well, right? To think about it in another way. Okay, so we got our select by count. Let's see, one last final thing, right, that I probably want to get through. So we talked about our semantic queries when we were saying, let's sort by duration and find the top 10 tracks, right? And how semantically it didn't really work because, I mean, it cuts off at 10 exactly, even though there's a tied amount of duration for 10, right? Even though a lot of tracks have the same duration at the 10th place, right? So what sort of things can we do to solve this using a subquery? Right? So let's say we want to find the top 10 tracks by duration, right? But then if there's a tie for 10th place, we include all of them as well. So how would we answer that? Or does anyone have any idea? I would say we select the distinct top 10 durations and then filter tracks of duration in those of subquery, right? Very, very close. There's a tiny issue with that, okay? Can you think about what could go wrong? Or can anyone else suggest what could go wrong if we select the distinct top 10 durations and then filter tracks, right? What use case might error out here? Or not error out, we could get too many, right? Exactly. Because what if there's tied for second place, right? If there's a tie for second place, then the 10th record, right, or the distinct top 10 records would actually give us the top 11 tracks. Right? So if we remove the distinct though, so let's say select duration from, right, tracks, order by duration descending, limit 10. What it does is it gives us the top 10, right? Gives us the top 10, and then all it says is, well, let's compare with this and find everything that's greater than or equal to this, right? So last minute, right? let's select all from tracks. I used Control C in that case. I just canceled it. All right. Select all from tracks. All right. Where duration greater than or equal to. Right. Select duration from tracks order by duration descending. All right. Limit 10. Okay. Does this work? Greater than or equal to all, exactly, right? Because if you're using a binary operator here, it expects or it only works if this subquery returns a single value, right? If it returns a single value, right, then it works. But because a binary operator expects a singular integer value, this doesn't work because it returns 10. So we could use, we could use in, right, where duration is in. Right? And we could also use, this gives me a lot, right? We could also use greater than or equal to all, which is saying compare it to every single duration here. And if it's greater than or equal to all of them, then correct, right? This is part of the top 10, right? Other ways we could do it is we could say equal to the maximum, right? Or equal to, sorry, the minimum out of the top 10, right? Oh wait, that doesn't work in this case, right? That only works for top 1. So greater than or equal to all is our friend here, right? And so yes, what does this query actually do? Right? And so yeah, I'm gonna firstly finish the session here. I'm a bit over time, right? Sorry about that. I'll stick around for a bit more after pausing the recording. We'll go over some basic questions, right? Maybe 15 minutes if you want to stick around, right? Thanks all for coming. And of course, SQL1 exercise is happening as well, right? So that's already out. Give that a shot. Right? There are some difficulties there as well. All right, thank you.